we look for opportunities of what type of infrastructure and technologies we can develop that can increase the throughput of development process at Microsoft. So we have different technologies and tools that we have currently deployed within the product groups in reliability and performance review. Right now, what we are doing is we are trying to develop a tools strategy for our own research and development strategy for .NET. So we are going through getting a customer perspective of what type of challenges you foresee, maybe current challenges becoming much bigger challenges or new challenges that you foresee as company moves to moving to that services platform. So we have done different these type of meetings with product groups, technology groups, people also within the research. So we are basically interested on what type of environment you work in, what type of challenges you currently face, and what type of challenges you see becoming as we move to our services platform, maybe become bigger or new one added to that you see. I think that is also one of the very big area that we missed today of how the technologies are going to be deployed is going to become much more important. Because CDs, the software is not going to be delivered to the end user the way currently it's being. And we find you are the closest match we see to what that operation center will face. So that's about the context of why we are here. If anybody likes to add something, Jim?
Yeah, the initial meeting that we had for the ITG folks primarily resulted in you guys being picked to represent ITG, primarily from you've gone through some pretty hard deployments, especially recently. And was there anything that you could think of that was especially challenging that if the product groups would have tested more thoroughly or had a tool to help test in that area that could have saved a lot of heartache from an ITG perspective, or were the things that came out in deployment where it was obvious they didn't think about looking at it that way from a deployment area? So that's how you got selected. We tried to pick the key people from a monitoring perspective. Frank, I think your name came up primarily. Were there better tools that could have been developed to help you catch things as things were crashing faster, that kind of stuff. So that's the gist of what I got as well from the action notes. So I'm not sure if it's just like jump in or if you want to have more structure to that.
Well, it would be if somebody can provide an overview of, I see you have prepared some presentation.
Yeah, actually, this has got a pretty high-level overview. Gets into more of the enterprise event management type of scenario, dealing with fault management. This could give you some context on our current challenges, how we're dealing with our current scenarios with our fluids and online properties in the internet space as well. So then I'll start.
Right, and then we can follow up with us asking questions.
Pass these down. I don't know if I have enough for everyone, but
Sure, we can share.
I got a presentation too. You want me to put it up on screen or?
Yeah, sure. Is it the same slide? Yep. Yeah, probably use everybody.
Was it my understanding that you said that people may have prepared presentations? That you did different people?
We were not asked to.
No, I think that basically.
Frank is just amazingly prepared.
No, I just want to clarify.
I think Frank's not.
I did my research. I'm showing off, right?
He's trying to make the rest of us look really bad.
No, that's fine.
It's just something I had in my back pocket.
But you guys should feel, I mean, definitely jump in if you have comments to add.
I mean, I came in a minute late, so I do apologize for that, but it'd be nice to know what exactly is it that we're focusing on.
So the gist is, do we as ITG have good feedback to this research about what they could develop for the product groups to help test the products, make them more realistic tests from, what our experience
So
with
this
the
is a product
challenges are.
evaluation.
Well, it's some form of deployment type of it. These guys are probably going to say it better.
Well, the testing and
I think the real context is we want to look forward into the .NET world and sort of ask ourselves what we should be doing in that space in terms of developing new tools and doing research for the benefit of Microsoft. And you're seen as people who are probably as close to it or as anybody with inside Microsoft in terms of managing the online properties and the entire network environment. And so we'd like to get feedback and insight from you about what the issues and problems are, where we should be looking to develop better tools, what are the really hard things to do that you don't know how to do now.
I'm sorry, feedback means that you give us something and we give you feedback, right? So you want to present to you what we are doing right now and see if you can do something better in that space? Is that what it is?
We'd like you to go really talk to us about the challenges you're facing right now and what you see in the .NET infrastructure in the future. Based on the input that we get from you, we might be able to tailor our tools or develop new areas where we can provide you with the tools to meet those challenges.
So going to the presentation of how things are done today is useful to you?
Yes.
Okay,
Sure.
that's it.
It's useful as a context, so we could ask you questions.
We really could use somebody to develop a good projection screen.
Some feedback. At the event, at least. Hey.
The thoughts
Kill the lights. I guess in the back.
The window.
Okay. I'm Frank Zakrajsek. Call me Frank Zach. It's easier. Last name's a tough one to spell. Currently, I manage the networking systems management team. So my team's responsible for network systems and telephony tools, monitoring, real-time fault management, implementation of tools, picking the actual selection set of tools that we put into our environments, and making sure that all of our instrumentation is set correctly so that whenever our infrastructure engineers or our service managers say, this is how we test the AD replication to SQL monitoring to IIS monitoring, we ensure that that instrumentation is correctly set. So as a quick synopsis, and the whole idea behind this slide is really to give you some context on event volume, the numbers of servers that we manage in our space. So from a centralized perspective, we're trying to pull everything in from basically the rest of the world into a centralized location for us to do our operational model of Tier 2 triaging, monitoring, making sure you're looking at the console and getting faults, all the way down to making sure that we've got the right tools on the boxes, to having the right people here in each of the regions fixing those issues. So our environment currently, a little bit greater than 8,000 servers in our environment that we have. Roughly 6,000 of those are production servers, 2,000 in the labs. This is not including a lot of the Unix boxes that we have in the Bay Area, so this is strictly NT from this perspective. Over 3,000 network devices that we manage as well, and about 110 data centers that we have worldwide. So from a centralized monitoring perspective, we've got a bunch of key processes and tools that we really rely on. First one is really the standard infrastructure. So that our engineering team sets out a specification that says, this is what we want from an IPAC. We call an IPAC an infrastructure basic, a package that we deliver as a set of standards of OS, instrumentation, all of that is set as a standard so that we track each of our customers or our installed base by function of servers, so on and so forth. So from a troubleshooting perspective, it's much easier for us to say, hey, I understand it's at this rev of the IPAC, so therefore I know all my standard specifications are set correctly. In our space, it gets pretty difficult to manage change. There's so many people involved, so many different groups, so many teams involved that can potentially make changes on our servers. So it gets really hard for us to audit and keep track of those. The next key area is really fault management. I like to break fault management out into 3 key areas. The first one is really our ability to detect the problem. So how well is our instrumentation set? Do we have the right tool? Do we have the right definition files looking for either an NT event or an SMP trap? Second portion of that is how fast can we actually get it to a console so that we can ticket it, so that we could get some visibility to that problem. The third portion is really the ability to resolve that issue. So you're actually doing your problem resolution phase at this stage. Another key function is really change management. This is really difficult in our space. Definitely one of our key challenges that we have to deal with. Again, like I said before, there's a lot of people that get involved in these changes, a lot of different teams. It's really hard to audit who did what when. Very difficult. Configuration management. Another area that every team in the ops world and engineering space really needs really good configuration data for servers by customer, by function, by the standard hardware, software settings that are set on those servers. So it's very difficult from our space to have one consolidated, database that has all of that information for all of our production servers worldwide. So from a centralized event management perspective, we've got two key systems, the computer systems and also network systems, that rely on some key tools. From a computer systems perspective, we've got Sentry and NetIQ doing our real-time event monitoring. From a network perspective, we're using NetCool and HP OpenView. So HPOV is doing the SNMP traps, taking syslogs all the way up into the NetCool system that does our real-time console view for network failures. Okay.
This data is also being logged on a continuous basis, or you turn these on demand basis? This NetCool.
From a network perspective, or
network perspective.
Basically, from a net perspective, we're just it all depends on what tool is actually being utilized. I mean, we do syslogs and traps that we're capturing, and then HPOV is out there pinging all the devices. Again, depends on the device, and then we're basically collecting everything back into a central repository. And I think I have a slide in the back in Appendix D, I believe, is the network portion, showing you all the inputs into our system, into a centralized location. So if you guys need any more detail on that stuff, I'd be happy to provide it.
So what is it that makes it hard to gather all the data together? Like you were mentioning about there being different people having different versions, the configuration.
So configuration-wise, the difficulty around that is there's multiple ways of doing it, right? You could use WMI, you could use a decom object going out there and collecting all this stuff and pulling it back into a central repository. The difficult part is actually reporting, let's say, to upper management or to an ops team to say, should this server be running this version of software? Should we have this relationship with this customer? So there's a lot of things that we need to track and basically gather. So there's a lot of people getting their hands in the pie. So there's potential room for, security issues. Well, I didn't want him to touch my server configuration data, but he did. He changed it from this customer to this customer, which changes our service level agreement. There's a lot of potential for gathering, useless data. So it's not so much from the gathering perspective. It's really more from how do you maintain the data day to day, making sure that it makes sense. So there's some data integrity for the actual users that are pulling the data out. I don't know if that really answered your question.
Yeah, that kind of answers. So looks like maybe one of the answers is actually at the time the software gets installed to check the data integrity there. Maybe influence that.
Well, see, we actually have a new tool that we're actually deploying right now. We have it on about 1,600 servers, I believe. It's called ECM from fundamental software. And it's a DCOM object that allows you to basically gather everything about that server. So registry, services, processes, stores it all into one centralized location. So we're thinking of actually extrapolating that in the future would be tying this into our change process, so that whenever a change happens out in the actual environment, we would store the differentials with that change. So again, we have a better chance of auditing what happens. This environment is very difficult to say, you know what, customer, I just really don't know what happened. We've got to go back into our logs, check it out, and it takes you usually a number of hours to basically deduce exactly what happened. So it gets really hard from an auditing perspective, especially around configuration management. That's really difficult from our perspective, because we're always backpedaling and trying to get our line in the sand and then say, okay, this is what happened at this point, and so on and so forth. Auditing is really difficult. Okay, this next slide, I want to give you a little bit more detail, a little more context of what we mean by centralized collection for an event management system. This pertains exactly to the network space as it does in the CS, so I'll just, you guys are probably a little bit more interested in the CS side of it. So if we take a look at the lowest tier on the managed nodes, we've got servers and desktops. And what we've done is we've instrumented all of these servers with agents that allow us to basically do event collection. So you have to process a number of events in the event log. So currently we're roughly processing a little bit greater than 200 million events per day using our agents. So there's quite a bit of churn going through the event log. So roughly on average, just a little bit under around 40,000 events per day are happening on our servers. So there's quite a bit of it. So our idea is really to take the important stuff out of that, to say which one is really, really critical, which one is really telling me I need to take some type of action from an operations perspective, and forward that up into a centralized repository so that our console can look at that and say, hey, I need to take action on this. So it's very difficult to get through all of these events way down here and say, oh yeah, I got a problem, and it's going to show up at the centralized console. So what we do on the right-hand side at this tier, we also have desktops that have Vital Suite agents on the boxes as well. This agent acts a little bit different as opposed to just reporting through the event log. It's going to be trying to do the synthetic transaction, see how well the mail is responding, so on and so forth. And eventually what we want to do is take it up to this next level and say, okay, let's do the correlation between, 50,000 users are having authentication problems. Hey, let's go check our DCs. That kind of mentality, so that we fire off an automated script in the background and say, okay, let's check through our whole architecture and make sure it's still up and running. So as we move up the tier model here, we get up to the mid-tier monitoring tools or management tools that we have in place. We have two philosophies here. One is really a polling scenario, and the other one's an agent-based. So the agent is basically just trying to determine what is the actual failure and push it up through the event stream. The polling model is kind of like the tool watching the tool. So you just can't rely on one single agent on a box to say, okay, how healthy or how instrumented is my box, and am I getting the right failures at the top tier console? Polling mechanism, you've got a bunch of different tools that we use, HTTPmon, Cluster Sentinel, SIM, HP Open Manage for the Dell boxes, going out there and just pinging, making sure that they're alive. You've got third-party scripts or WMI scripts or NetIQ scripts that go out there and basically do the same type of thing, but actually go through more of a synthetic transaction, logging into a SQL database, actually trying a transaction, that kind of mentality. So as everything is started going into the centralized event stream, we get into the top, just actually below the top tier from a collection standpoint is our consoles. So it allows us to have a consolidated view of what's happening everywhere, or you could have an operations, a production manager's specific view, or like a service chain view that's specifically geared for this customer, so that you might have two clusters behind WLDS, 5 or 6 SQL boxes, and a couple file and print servers, and only those would be visible in their console. The top tier is really what is actually happening with each one of our core services, so that, hey, how well is mail doing? This is something in the future. We haven't got to this level, but eventually we want to get to it. How well is mail doing? How well is the authentication, the DCs working, so on and so forth, so that you have a detailed health state of what's happening in your environment.
So basically, tying those logs to a specific service. So what are the right events that you could tie to say
Right.
this mail? What are the right events?
That's right. That's so true. I mean, I have a whole list of challenges that we'll get into, that type of detail that we're really missing in today's environment. And it's really hard for us to deal with those type of issues. Especially when you're dealing with a consolidated, centralized team. It's not that bad if you're only interested or working with 100 servers at a time, and you have an operations team looking at a very small select set of numbers. But when you're looking at thousands, our team, we manage about 5,000 servers, which is a little bit under the 6,000 because there's other operations teams that actually manage the other ones. But when you're dealing with that many servers, it gets really hard to determine root cause. It's really hard to get it all the way up to the top tier and make it there with some type of priority. Priority is missing in this whole model. How do I make this server that's an SAP server a higher priority than this one that's MS Market or MS Expense or something like that? How do I change the priority of that event in the event stream? That's a key thing for us. Okay, this is our current event architecture. You guys probably can't see this, but in each of the regions, this would be a EMEA region in Europe, the Asia region here, and North America. There's some green lines here. The first part of this is really to regionalize your collection of your events, SNMP or NT events, into a collection point. And then at that point, you only forward all of the important stuff over the WAN back to a centralized repository again, that we again can see a consolidated view. So if you take a look at some of these numbers here, you're looking at greater than 5,000 servers in our environment from the IDC space. When we talk about IDC, we talk about internet. The CDC is the corporate environment. So you can look at some of these event volumes where between 6.5 million and 20 million, depending on whether security wants to gather the log off and log on events, and we ship those off to the security database, that kind of stuff. Huge alert volumes. So we're processing at the lowest tier roughly 200 million. We're gathering roughly about 20 million at the next gathering point, which are really located here in each of the major centers. And then from there, we're basically having maybe 100 to 200 problems per day in our environment that we need to take some type of action on. So you can see how much you need to process all the way through to get up to actually cutting a ticket and getting someone to either manually take some type of action, or again have it automated so it's happening in the background. Another key feature here was that 99% of our servers worldwide will report in under 90 seconds through this framework. So it was really key for us to get notified very fast. Okay, some thinking behind, how do we pick the tools, that kind of stuff. What are our key issues with this type of an architecture? We wanted the ability to do some alerting, filtering, and discarding. When we say alerts, we're basically forwarding a critical, severe event all the way to the top tier so that we need to take some type of action. Filtering, again, is discard. We still need to process it, but we still, it's basically throw down and away. It's got to be scalable. That's always an issue in our environment. I think when you look at any tool that you try to put into this space, when you're looking at, start going over the thousands, it's tough to scale. From a collection perspective, it's tough to scale. From an alerting, monitoring perspective, things start to fail. There's the stuff on the back end. How do you make sure that you have enough room in your database as you have alert and event storms? That kind of stuff kind of kills you without you knowing it until it's too late. So, it's that type of scalability issues. The console has to obviously, handle event duplicate suppression. What we mean by that is we want to take out all of the duplicate events and replace it with one, showing you that, yeah, I'm getting multiple of these. Think of it as consolidation, and only the date and time is actually updated, that kind of stuff. Event delay, like I said before, has to be under 2 minutes so that we're getting very fast notification to the top tier. Want to be able to gather some of the important alerts or even events. I mean, you could take it informationally and say, you know what, I want to change its state from an informational to a red alert because I know it's important and it could have been coded wrong from the application, that kind of stuff. Event correlation is important. You want to be able to do it on a single server to say, I see this error and that one and that one. Send one event that actually equates to, let's say, a poor service or something like that. Or you want to be able to do multiple service from a correlation perspective. So you can take multiple, let's say a service chain where you have, let's say a SQL box, a web server, and a print file box, and say I got a couple events here, a couple thresholds there, and then say I have a major problem with my service chain or my cluster. Event consolidation is pretty straightforward, frequency filtering, so that we're not spamming the console with all of these events that an operator doesn't know what to do. Just send one. Obviously, the memory footprint must be low during peak load, so that any customer is going to say, well, geez, why is processor so high when my box is going down? Well, the way the tool is designed is basically to report failures. So as you have more failures on the box, it's just trying to do its job until the day the box dies. So it's a real tricky trade-off. If you have a very chatty box generating a lot of alerts and it's going down hard, your tool is going to basically keep on rising the CPU utilization too. So that's a very political, tough question to always solve with a customer because they're very conscious of the whole CPU situation and a lot of the resources on the box. Per month thresholding. Obviously, not all the applications out there instantiate perfmon, but it would be nice if we had some type of a healthy, poor degraded state, and boy, I'm really dead now state on each one of our core services or technologies that we put out there. Another key requirement was corrective action automation. What do we have? What can we do to actually fix the situation? So if you know that the box is ready to tip over, but we have an automated script that can catch it and fix it, can we do it? And that's you hear this whenever you talk with CA or any of the framework type tools like Tivoli and so on and so forth. It's we've gone from reactive to proactive, and then eventually we want to get to this predictive state. It'd be nice if you get to this, corrective automation. I know it's going to be failing here in the next 2 minutes, and let's go fix it before that happens. The last part is each one of these tools have to be very flexible, extensible. They have to fit into our operational model as that operational model changes. Especially with this whole .NET, I don't think anyone's aware of what's going to happen in this space. So it's going to be tough. I mean, the operational models will change very quickly in this space because the need will change. And I know it'll probably be difficult for a lot of the product groups as they come into this space. From an operational perspective, it's going to be difficult to manage this space. Again, most of us don't have that kind of a background in operations in the product groups. Yes?
So, just a make-believe question, because I'm curious on how it displays. If in make-believe land that you could cut your number of servers down to 100 because there were much bigger, more scalable servers, what effect do you think this would have on your management issues and everything else? Would it make it more wonderful and easy, or would it have no effect?
I know this is a trick question, isn't it?
It's a dream question.
I would go with reducing the total number of servers from my perspective, but that's not the greatest thing for the company, obviously. But if you could reduce the number of servers, from an operational perspective, it would be easier to manage. But then that's the tricky part is you need the tools to say, obviously you're going to have multiple customers with multiple applications on those servers. That's where it gets tricky. The way we solve it today is, no, just give SAP another server. Oh, no, give MS Expense another server. No, give, Microsoft.com 5 or 6 servers. So that's the way we solve it today. But if you're going to get into a situation of reducing the total number of servers, you need a way of mapping, customer to application to server. So it gets kind of tricky. But as long as you can solve that, and you could delineate what those failures are, when you get into any kind of shared type of services, it gets really difficult from a management perspective as well. So I think I would love to have the reduced number of servers, but I think it would be another new management headache that we're probably not aware of today.
I was just curious on how you do it. Yeah.
I don't know. Anybody else from ITG? What do you guys think? Would you go with the reduced number of servers, or
if they work flawlessly?
Well,
well, that was my assumption. Right?
You'd have to consolidate services and/or customers on the same box. That's going to cost all sorts of money. Especially get multiple customers on the box, just trying to schedule a reboot.
I mean, you have to ready priorities, schedule downtime.
Well, if pay stub brings down SAP server, you're just never going to get people to agree to something like that.
Plus, I guess the whole move has been towards distributed, right? And .NET will probably make it more that way than less that way. I think the central big computer is sort of dead. And trying to reduce the numbers would just kill the flexibility of the .NET environment, in my mind.
I'm trying to understand not what's reality, but what people really want. I mean, what I'm hearing is Nirvana is a single box that never crashes, that can deal with a worldwide load.
Well, but
that's not reality.
Well, from my perspective, that's easy.
From operations.
But quite frankly, I think what we've heard here is the amount of effort and work and the complex structure you need to be able to run a large data center like Frank is talking about, and be able to know who's breaking and whether that's someone you need to fix, and if so, you need to be able to do it fast. I mean, that's basically what all of this is about, and he's got to pull together a whole set of tools and do all kinds of things to make that happen, and obviously that's not good. And if we're talking about creating some possible tools here in the future, and we're not talking about 2 months down the road, but in the future somewhere, then we're going to be talking about self-diagnosing, self-healing systems. Quite frankly, that's where we ought to go. And then all this stuff would be thrown out the window if we had. That would be nirvana, okay, in a distributed world. The server telling you, hey, I'm going to die in a half an hour, I need this part, sending out the call, getting the power fixed and stuff, whatever, that would be it. So we ought to be developing tools that help drive in that direction. But when we'll get there, I don't know, but we certainly can start building tools that help do self-diagnosis and, to the extent possible, self-healing. Take yourself out of a cluster. I mean, we kind of do that today with some of the tools right now.
I'm hearing more than that.
But you wouldn't need all that stuff then if you could do that.
I'm hearing that I would really like a single image system.
A single one?
A single image system, that's what I'm hearing. That, okay, we've got 8,000 machines. The problem appears to be that they look like 8,000 machines. If they look like one, it would be a bit better. If when a node failed, the work went on to another node and just carried on. That's what you're looking for. Sorry, as I said, it's a fantasy question. I asked you to understand the mentality, not to sort of...
That would definitely help for configuration management. And we've actually talked about that in the context of SANs. We see a number of situations in which we have a bunch of distinct system images that we have to manage configuration on, and we wouldn't necessarily have to do it if we could have a single image that we could boot a SAN off. That might replace, when one fell swoop, we might be able to replace 20, 30, up to 100 separate system images that today we have to track and manage and configure.
But then you're transferring your system configurations to partition configuration.
Right.
Yeah, and that's all you're ever going to do, even if you go to one monolithic system, you just change what you monitor and what you fix.
Your requirements to monitor and diagnose on a per process or a per application they're not going to go away.
Right.
You might be reducing some of the instrumentation around hardware monitoring, right?
Right.
That's about it. But when it gets to the complex, end-to-end script of your service or application or your technology, you're going to have to write that in, no matter whether you're distributed or centralized.
The diversity is not going to go away. You're right. But I guess what what Frank is translating to a single image, well, can we have less diversity in the diagnosis and the hooks that are out there that all the different services or products produce? So that could be unified. So having a single body, if you want, of hooks that Frank doesn't have to distinguish, doesn't have to learn about different services or applications in order to manage. So from an administrator's point of view, if you want, give me this administrator's view that changes very little from service to service, from product to product. At least if that doesn't change in format, then that will help operations much more, because then the ramp-up curve for each one of these services, is reduced to almost nothing.
But again, I contend that even if you do that, that would be a great help, right? Because it'd be a lot easier than to see what's going on. But again, a lot of the time, then once you find out what's going on, a lot of time is spent trying to go to that server, figure out what's wrong with that server. You may not get it the first time, and you have to reboot it 3 or 4 times till you finally figure out what's going on. Then you finally find out it was a card somewhere you have to replace. So even if you do all of that, you still have the issue that you have 8,000 servers, and you still need to react to them, even though now you much more efficiently are able to find out what's going on there and deal with it. The idea of self-diagnosing is important, and I think you still need to add that on there, because that would make life easier then from a management perspective. Well, not only do I know who's hurting, but I have a pretty damn good idea what the problem is with that. Today we have a debug team. Sean here is the lead for that, and when something fails, they need to go in there and debug the server. I mean, it would be great if they didn't have to, right? If the server was telling them basically the 3 pieces of information.
Don't take it that far.
We have another job for you, don't worry.
We'll still let you look at the kernel bugs.
But you have to manage that one box.
But to the extent that we can automate things of that nature, will make it a lot easier. And we're happy to debug here because we're Microsoft. But the rest of the world is not, right? They don't want to mess around with the damn server. They just want it to run. And certainly the .NET space will want even less to do with it. They'll just want to run a business. So things that we can do that help towards all of that, having the hooks, making the structure more simple, and also giving the most information possible about what's wrong and what to do about it, will really help greatly on things of this nature.
Okay, so current challenges. Obviously, we touched on the volume of events. We just have way too many NT events, SMP traps. Now, you're talking about 200 million that we process every day. We roughly gather 20 million of those, and we have about 100 to 200 tickets that we generate for known problems. Obviously, something's broken in our methodology of how we're dealing with NT events as a company. It would be nice. This is my nirvana, is having only unique NT event source IDs, event IDs that are critical. So that are actionable. We need to only collect those. We can't just have 50,000 of them. Like SQL. SQL's a good example. Same event ID, same source ID. The only thing that changes is the actual text. So all of our event processing is happening on text, which takes time. So it slows down our ability to respond and also detect those issues. That's just garbage in my mind. I'd love to be able to say, you know what, I have an actionable event here, and I know exactly what to do because someone told me to do it. The way we've done it is tribal knowledge. The last 4 or 5 years in this space, it's been, okay, we've seen this event, and we debugged it, we went through this, and this is what it really means. So what we've actually done is we've replaced, we call it friendly text replacement on the console. We've taken this cryptic string of text that says gobbledygook 979354, we replaced it with, your hard drive bill. Please, replace hard drive. And it's amazing how much easier it is from a console perspective when you talk about a globalized, centralized team looking at 5,000 servers worldwide. How much easier it is. So that would be my number one suggestion. If I had that, I'd be way better off than I am today. I don't care about the 200 million. I'll never look at them. I won't even look at the 20 million that I gather. I mean, some portions of the company, like security, yep, they'll definitely run it through their test machines and so on and so forth. But I'm not going to look at it. I only want to know stuff that's actionable to me. Known failures.
But they can't control that. It's actually the application. It's the SQL team that does that.
But
not from a school perspective.
So do you need better filters, or you just don't want them to produce it in the first place?
I think that's a good step. Not producing. I mean, there's bogus stuff out there. I mean, we've got informational events that I have to process because they're generated. I mean, why are they generating 30,000 events per second? You know, not 30,000, but 30 events per second. But why are you generating that many when WINS is failing? You could tell me maybe 1 second. Why not? You don't have to tell me 30.
But WMI can handle that for you today. Can suppress that.
Yeah. Oh well. There's tons of tools that can do the suppression. The real issue is why even bother writing? You know, just.
So you think some of these events are of no interest to anybody under any scenario?
Oh, for sure, absolutely. No
Especially
question.
on frequency.
Consolidation is great, right? Yeah, if it happened 50 times in the last 5 minutes, I'd like to know one event that happened 50 times.
But is it also an event architecture issue that you have these diverse environments gathering events, and you don't have a way to control a hardware event versus SQL event versus OS event?
Yeah, I mean, it would be nice. I mean, there is a category field there, right? No one really uses. It'd be nice to differentiate between an OS event and a hardware event. We've done it on our own back end, so we know the difference between a hardware, OS, and so on and so forth, whether this is specifically to one application. So we've done that as a workaround.
Is there an industry-wide initiative that somebody...
There isn't a company-wide initiative.
No, see, that's the
what we need.
You know, it would be nice if you just said, okay, 100 to 200 belong to SQL, maybe 100 to 400 belong to NT, you know, that kind of stuff.
So when you go to SQL and tell them this, what do they say?
You're right. We have dedicated headcount to just interact with SQL on this topic alone.
But what do they say? I mean, why do they have all these events?
19 months, and they'll be able to address some of it.
Yeah, unfortunately, the reality is that typically in those groups, the events, I mean, there's two ways that the services speak to the administrator, events and performance counters, and, you know, other hooks that now surround things like WMI that gets the information from other providers. But all those hooks are basically not standardized across the company, and they are typically very low priority in all those teams. They're usually given to like a summer intern that comes over or something like that. So the definitions and whether that's useful or not are who is that useful for? The developer, the administrator, who is that useful for? It varies across different products and even within the same product. And there is not even, you know, the original standard, so to speak, like Frank was saying, source, category, event ID, those are not respected at all, and they overlap. I mean, so
even within the operating system, the standard categories, you go to one component owner within the operating system, and they have their own ideas of what an error and informational and a warning are. You go to another component owner, and pretty much everything they generate is an error. And you know that their component will work just fine in some cases whenever they're generating supposedly these hard errors. So because for one thing, you only have the granularity of the 3 different types of events that you can log there, and for another, because you can't get any 2 component groups to agree on how to use those things. You really can't use a standard methodology for what are the best events to track, or what are the most serious events when something's going on with your system. There's also no correlation. If my gateway address is wrong on my PC, every one of my services that relies on some sort of communication is going to log some event, rather than realizing that the single event of having your gateway address set wrong is what's responsible for any system failure.
And you also only learn about events when the product comes out. There's obviously there's no taxonomy for any of this. Nobody's building a list and saying here's what you're going to have to work for. And And even as it happens, I mean, after going to Windows 2000 the last few years, I mean, we've seen new events all the time. What is that? Hell, I don't know. What is it?
It's got to be important to hit the console.
Yeah. But I mean, you end up with the developers as confused about events as you are. Because just like the other gentlemen are saying, it's very inconsistent, it's not a priority, and maybe it is that summer intern.
Yeah, one of the problems I see is a lot of the design is done in a work group mentality, which means it works great in your office, it works great in the 6 test servers you have shoved in the closet somewhere. But once you start getting it out there into an enterprise application, it falls on its face in a big way.
In many ways, not just events, but
yeah, this is designed. I've seen this in NT, in logging, in Perfmon, in everything.
And this is just half the equation, because even if the eventing model were perfect, you still need the methods and procedures of what to do when that event occurs. And as Frank said, those are only gathered through time, and like Frank called it, tribal knowledge. And that is not provided almost in any way.
Yeah, I think
thankfully we have the KB. We use the PSS KB quite a bit, but the scary part is when you look it up for an event ID, and the only one you find is your SR, the PSS. Then it becomes terribly frightening. That means that this has not been documented anywhere.
Yeah. And most of the time when it's a KB, it's a real bug. It's not something like change your disk or something like that.
Right.
Yeah, it's got to be actionable. I mean, it's either got to be actionable through a script. So you could fix this by doing this,
or at least you have
manual intervention.
To be able to filter by some, which ones are actionable, because granted, the eventing mechanism is presumably not done only for administrators. There's information there for someone else, but at least putting a filter there that filters the actionable ones, whether that you're giving a method and procedures book of what to do with each one of them, that would be a service to
a taxonomy, just of events would be sweet. Changing the priority would be even better. I mean, giving a higher priority or precedence to SAP over somebody else and that kind of stuff.
From a console perspective, but then from the model perspective, it doesn't know that unless you go into your Nirvana model that you want one server.
But I think that could be generated as afterwards as a whole company. It could be any company saying, okay, I think SAP is number 1, Microsoft.com might be number 2, and so on and so forth. But from an operational perspective, I mean, the .NET space is going to have the same issue, right? You're going to have multiple applications running on either, your services. Which one has higher precedence to get fixed first?
So I'm just curious, what do you guys feel is the ratio of problems caused by different servers having different configurations, i.e. the configurations around a sync, versus problems not related to that particular issue? I'm trying to figure out, how bad is the fact that it's just the number of servers and the fact that configurations.
It depends on, configurations mean a whole lot of different things. Configuration in my mind means how the tool, if the tools are there, if they're installed correctly, if they're configured correctly, that we're actually going to trap an event that happens.
Right.
Versus the applications installed correctly and or the same version.
I'm thinking of machine cloning. So I'm saying that if you could truly clone a version of NT with all the tools and all the software, and you could say, look, this machine and 8,000 like it are identical. I guarantee every bit and every byte on them is exactly the same. How many problems would that solve for you, do you feel? Just a handful?
Instead of having, like we've got customers with all sorts of different configurations, we do it ourselves. But if you have one configuration for every customer, and then they fit that mold.
Yeah, but you think you get all the customers to agree on that? I mean, let's face it. I mean, we do have 55 standards, and they are standards, right? It's their customer standards. It's hard from our perspective, from an operational perspective, to debug and triage and try to make sense of that.
Well, every time
standard operational
hardware comes out, you got a new driver. Where does that do the configuration? You don't upgrade 8,000 servers to those cards.
But is Microsoft unique to that? Because we allow our customer a lot of power in what they choose to run on, whereas other companies are going to have a more lockdown methodology.
Yeah, I would say we're probably a little bit more flexible in that arena, but I still think a lot of customers deal with the same configuration nightmares, right? You can still have multiple people going in there and tweaking and making changes. You just don't know about it, right? So, at least here, we know Microsoft.com is playing with their boxes, and we know XYZ guy is playing with their boxes, and so on and so forth. And then we're on the hook for explaining exactly what happened, and we're sitting there going, oh, I don't know.
I want to just say one thing that will help ground the box number problem. Is this problem exacerbated because of sheer numbers of boxes versus just a poor implementation of an event model? And clearly, it is a poor implementation of an event model that just exasperates itself due to sheer box count. I mean, that's the differentiation you need to make. And talking about this Nirvana world, it's still a poor implementation of an event model that's going to kill you.
So a number of things you need to monitor who stays in.
And it gets even worse when you're really selling software as a service. People are going to want to know, how many.
One of our greatest fears is why we push back on the SIS stuff is because finger pointing occurs when you start stacking different services on the same box. Even today we have problems with, okay, is it an NT problem or is it an Exchange problem? And sometimes locking the testers or devs in the room is the only way you're going to figure it out. But I've actually seen calls go from Exchange to NT and back because it was being troubleshot wrong, or it was very confusing, or it was just a mix of both, and they literally both need to be troubleshooting at the same time. But once you start adding additional services on there, okay, so I put Exchange and SQL and Web on the same box, and then something goes wrong. Who do you blame? Who do you talk to? Who do you escalate to? Because your service teams are very different and have very different focuses. Now, if they all ran in their own memory space and didn't trample on each other, and the operating system stayed out of the way as well, then I think the number of problems would be reduced. But that's simply not the model that we have.
That's your Nirvana box.
Oh, yeah.
Thank God we don't have a single machine there.
Yeah. Well, we're still aiming for that.
Okay.
The management model of that is the other piece that it's from a permissions granularity standpoint. We do service layering today in the field, and we do it on a lot of the infrastructure servers. Even with infrastructure components, which ostensibly ship in the same box, you can't necessarily set it up so that one person can only manage one component without the corresponding administrative rights to trample on some other component in the operating system. You still essentially have a mentality, even though Windows 2000 gives us a lot more permissions. You still essentially have a mentality that for most services you have to be the equivalent of an administrator on the local machine in order to set them up and configure them correctly. That poses specific problems for us when we want to do things like have a print server administrator that can add and remove print server drivers on a local domain controller in the field. We have one box that's both the domain controller and the print server. How do you make that work? And that's a very thin example, but I mean that kind of problem exists in different components.
That would point to a flaw security.
Yeah, it's not just flawed. It's just not. It doesn't provide the segregation.
It's granular as hell. It's just
it's extremely
stop
granular.
it. It's too broad. Each layer is just too broad.
We have situations in which you have to be an enterprise administrator to do things in a domain context, which means we've got to get some field tech who's never seen Windows 2000 before enterprise admin capability to administer a field domain controller. That's dangerous.
But we also have the similar problems with the types of monitoring tools that we have. They need a certain level of rights, and certain groups don't want you to have those rights on their boxes, and if you don't have those rights, you can't get the events, you can't monitor them. So.
Hey, look, I'm SAC. Cool. Hey, nice. Yeah, actually, then you get into the finger pointing. And,
so, I guess since you've been able to answer a few curious questions, I mean, I have a ton of curious questions. You're hearing our pain. What's your thinking? I mean, is it just fact finding? Hey, these guys have some real problems. What can we do? Or is there anything in the pipeline that you have, that you want to try to leverage into solving some of these interesting problems. Because we had a similar little discussion with one person from research, and a lot of great brainstorming, a lot of great ideas, and we talk about tools that can isolate potential memory leaks and encode paths that ship a different DLL, and you don't even have to do too much with it. I mean, that was an interesting thing. Then we said, well, could you leverage that into the event space and start scanning event streams before the code ships and see how many duplicate trash event IDs we have, and it was like the idea was there, but I don't know where it went. So kind of curious to figure out what you guys are thinking, what you're going to do.
So for me, the thing I'm thinking about is SMP scalability. If I can really make products run on 32 CPU boxes and 64 CPU boxes, am I wasting my time, or are people going to just jump for joy? What I'm hearing is it's worth working on that. It would solve some problems, not all, but some.
How would it scale compared to 64 single processor boxes?
Literally, that's what I'm talking about. I mean, it's a lot of hard work to make that happen.
Yeah.
So I'm saying, am I just wasting my time even trying? Or is this something where there's a payoff? And what I'm hearing is there's a payoff if we can scale. Because we sure as heck don't scale now. Not even close.
Well, I don't know how you jump to that conclusion, because some of the issues, like you yourself recognize, the reason that we identified as separate boxes is because we happen to have most of the applications isolated in this box. You put everything in one application that is 64 times bigger, and now the issues are going to be the same. It's just that I'm not going to be able to say, hey, it's because of so many boxes I have. I'm going to say it's because so many applications I have in that box.
So what you're saying then is that we don't have multiple servers running SQL Server.
No, we do.
No, we do. What we don't have is too many servers that are handling multiple applications.
Multiple SQL applications?
No,
So
SQL
same
Exchange.
Right, so I'm saying if you could factor all the SQL boxes down to one,
Right.
that this might help.
Only assuming if all those applications that run on that. So let's differentiate between SQL as the engine and then the databases that support an application that sit on top of the engine. If the databases that sit on top of the engine, with their analogous front ends, that we have a web front end, all play nice and all have components that behave nicely together, sit on that scalable 64 processor box, great. But if those applications that sit on top of those engines don't play together, the fact that it scales to 64 processors is irrelevant, because they're going to cause problems.
You really put the web front end on the same box as SQL Server?
That's what we're talking about, consolidating box counts. And this model that Frank showed you, well, it's worth it. It's worth going into. And the model that we're talking about, it's a 3-tier architecture. So there's an application server. There might be one type of SQL Server for front-end traffic, and there might be another type of SQL Server for back-end traffic. Those add to the number of boxes we need to monitor. So now, why do we separate that way? Well, we separate that way for security reasons, and also isolation.
Yeah.
So in your model, the reason why we're going for isolation is because if there's a fault, we only impact that part of the user experience that would require a back-end dependency, not just basic web page serving. In your model, if there's no oscillation, though we have scalability, you're out for the count if you have to reboot the box. Though SQL Server had a problem, web still could have been running and it can't.
Yeah, but that doesn't eliminate his, redundancy. He doesn't say.
No,
he's not saying, you've got this 36 CPU and suddenly that's it. I mean, you're talking similar to IIS. One thread really, wipes and stops everything.
In fact, a lot of those big box environments are running in partitioned environment, where SMP type of scalability is really not going to the whole machine level.
No,
they are just partitioned machines
correct.
And running multiple versions of OS.
I mean, we see other scalability. I mean, we've already looked at the linear problem. I mean, or lack thereof. For certain things.
Lack thereof.
But if you're doing simpler partitions, then you're still going to get the same amount of events out of the same box. It'll be just as if you just have, if you say 100 partitions, you'll have 100 boxes. What's the difference?
Right. So, your question about how does this information get used, I think one of the things that I can answer is your information we gather it heavily influences the investment priorities we put on, or what type of effort we put in. We're, in research, your domain experience is a big thing. Anybody cannot just work on one thing. You have to make a conscious effort. So we have to make a choice whether we work on scalability, whether we work on monitoring something, testing something, diagnosis. In that sense, we are looking at today, the information from today, that being able to monitor and diagnose the distributed environment today is a very, very big opportunity to give us competitive advantage and also solve some of the deployment issues. Do we make a choice in there, or we build more testing tools? Do we invest in making better monitoring diagnostics? So that's the type of information use at this point that I can give you feedback on, and clearly we don't have. Then there are other synergies. We have some existing infrastructures that are available today that are part of our tools that we could look at how they could be used to solve some of the problems you are facing today. But I think that we need to do a follow-up on an individual basis where we give you an overview of what we have available within our team, and we can arrange that. We can point you to information we have on our website, or we could arrange it. What are the infrastructures we have already in the areas where in the reliability and performance areas that could be retargeted to solve some of the problems.
So maybe we should ask, do you have anything that addresses these issues in any time frame? Or are you actually looking at these issues, or this is just an open app to see if you would like to get in?
Well, as I said, this meeting is about getting input from you before we build our future strategy of what type of investment change we should make for .NET. That's the step where we are at.
But at the same time, yes, we do have infrastructure technology that can help you with some of those issues. We cannot help you standardizing what the other groups, with respect to the event model, said and everything. But part of the things we provide already, which is instrumenting the binaries, and the next release we provide dynamic instrumentation, which means you'll be able to attach any process, any service, and say, okay, maybe the problem is coming from here, and I might solve some of the problems. But at the same time, what you have to say is that we want to see what else can we do in the future. And we provide code coverage tools, which can tell you some of the things.
So I think the best model for that is, instead of us telling you what the solution is, that we have a separate meeting where we give you an overview of our infrastructures or what they are capable of doing. And then we brainstorm a solution, a short to medium term, that could be built on that.
Part of it is like, throwing out the idea and getting us to think creatively on how we can leverage that, and then also you guys here on our team, and having you guys think, trying to create a patent, trying to do something.
So focus our research effort that where, it's not, we can't promise payoff, otherwise it won't be research in that sense.
So one of the things that I find interesting is this emphasis on the events and the event stream as being the central problem facing ITG. And I'm wondering whether that really is true, or whether there are sort of a lot of other issues that maybe are hiding behind this.
It started because Frank, that's Frank's world. He got up to talk about events, but if you canvass the group here, you would find different things.
We've mitigated a lot. We've actually built a lot of systems internally, and customized systems that customers aren't going to have that minimize a lot of the pain. The whole perf call system and how to collect performance metrics.
Like to hear that.
Is an example of that.
Frank, you have more slides, right?
Yeah, I can finish up here real quick.
Right, and then...
Yeah, eventing is actually just one of my expertise. Second of all,
let's make sure we try to get all of them on the table today, so we can come back with as much as possible.
I'll finish up here in the next couple of minutes. Another problem that we face is really, it's difficult to detect the health of an application or service. You just don't know the state, whether it's up, down, degraded state. It's one thing to worry about service control managers saying, the service said it was up and actually was hung, that kind of stuff. To the point before, perf call, the whole idea of instantiating performance counters, thresholding, integrate into complex scripts for automation, that kind of stuff, availability collections, that kind of stuff. Another key area is really to have an end-to-end test of each one of our services or technologies that we deploy. It would be really nice to say, okay, we could test DNS this way. This is how we test WINS, DHCP, proxy, RAS, all the way down our core services. Right now, we don't. We either rely on internal expertise, run over to the dev group and say, oh, how do you do this? And they're like, okay, this is how we can do a portion of it. Or you got a third-party tool that you buy, and it only gives you 3/4 of the answer you're looking for. So that's difficult. But as we get into this .NET space, it's not just an eventing model. It's a combination of events plus end-to-end tests to verify that you're truly done. How do you account for the client experience in this model? The client's going to be calling in either modem, whatever, getting access to all this data. At what point do you differentiate between the network, the data center, and then the actual client experience is connecting? That's going to be really tricky. The last point here, really, from my perspective, is it's really difficult to correlate network and server outages without having some kind of combined event stream from the network space and also from the CS space. That's what we're moving towards. We're about 80% there, so that when a switch goes down, XYZ number of servers are basically our customers are notified of all of their server outages. That's something we're really working pretty hard on to get, because it's really hard from a perspective of notification. It's really difficult to say, okay, this switch went down or this router went down. It's affecting these number of users or these number of customers out there. Very difficult. So with that, I covered the last point pretty much in the first couple of slides and changed. But I got a couple of appendices to this last slide here. Is just a future enterprise combined event console is what we're moving towards. So that's the whole idea of combining both event streams so that we could have that correlation between both environments. And obviously that's going to be a tremendous issue when you talk about the Microsoft .NET platform as well. You're going to have to know about all three environments: the client experience, obviously the data center, the CS perspective, and also the network perspective. Some type of correlation between all those three areas or environments are going to be key to know the overall health of the service. So with that, thank you. That's it. Now we get into some more discussion.
So Mario, you want to go next?
I'm a Mario.
I'm sorry.
Mario left already.
Oh.
Oh, I mean, no, I do. I think Frank
You
somewhere.
get shy now?
Is your team also implemented this system to log this information? Because you're using different mechanisms to monitor, and then you're logging the backend repository, for example. Is that a SQL repository?
Yep, it's all in SQL. Actually, NetTool is Sybase, but we have another impact solution called that basically pulls out our Sybase and pulls it in SQL.
So this implementation of this repository is under your team?
Yes. Yep. The design, the implementation, and also the maintenance of it.
You also mentioned about filtering some of the events that come from other places like Europe. We had a slide there. And so that part of filtering is also done by you.
Yes. So we set they're called, the tool that we use is Sentry. And we have an ADF, it's called an Alert Definition Filter Rule. Think of it as a policy that you're using for each one of your events that come in. So if you want to forward one or change its severity, you can do that. So you can take an informational and say, you know what, this is really important, and then change its criticality and move it up and forward it to the console. But you could also at the same time collect events for availability, because there's a bunch of events that you want to collect as well for availability of service as well.
So you already have ways of determining which events are important.
Yes, but again, it's a painful thing. It's like I said before, it was tribal knowledge over years of experience saying, yeah, this one's more important than this one.
We have a way of implementing it once we know which one's important. We don't know which. We know out of the group that we have marked as important. We know they're important, but we don't know from a global perspective.
So each time, so what you're saying is that each time a new event, the type is introduced, you have to go and change it.
Right. So we got to get together with the engineering group, dev group, and say, okay, what's important to us from an ops perspective? Is this one? What do I need to do? My team need to get engaged.
With the exchange services, I'm not sure how much you're running now, but we did it for several years. we did is we collected all the events off of every single server. In Redmond, we did it daily. The others, we did it weekly. Collected them all into a big database, and then we use what's called the event log filter, and you filter out the stuff that you don't care about. So then you get a report of the things that you don't know about yet. And then what we do is we ship that off to dev, the report, and they give us feedback on it. And then we update our filtering and do it the next day, over and over and over. And that's the kind of mentality you have to go through. And when you get to a new version, you start the process all over again.
We should also say that this collection process is based on third-party tools, so that the solutions that have been provided are things that you go outside of Microsoft to find a solution.
What are some of the differences in type of things you monitor between IDC and CDC, with the internet and the corporate environment?
Instrumentation is a little bit different when you're talking about IIS and SQL. Like SQL is basically the same. The IIS portion is totally different. They use different tools to monitor each space. I think that's probably the biggest delineation. Infrastructure is much bigger in the corporate environment. So the instrumentation of DCs, CISP servers, and so on and so forth is totally different. We don't have those in the internet space as much, obviously. But those are pretty much the biggest delineations. Yeah. Application specific, obviously the server-side objects in the IDC space seem, again, more dynamic, a lot more of them. So when it comes to a web environment, the philosophy of testing the web environment is different as opposed to the CDC space.
So trying to understand how you're disseminating this tribal knowledge you keep referring to, how do you leverage that with support? Do they call you and say, hey, our customers have run into this? Didn't you see the same thing when you deployed this within Microsoft? Is there any kind of exchange between you and PSS when the real customer runs into the same thing, or you really don't?
We hardly ever deal with PSS.
Really?
When you talk about like failure detection.
Right.
It would be nice if a customer actually called up that politely and said, hey,
well,
how come you didn't see this was down? I'd actually like my job. What usually happens is that, why didn't you see this? And then we'd say, well, geez, we got to do some research, no pun intended there. Go and find out what happened on the box for the last couple of days, go through the logs, and then figure out, did we miss something? Was the alert definition rules set incorrectly? Do we need to change our instrumentation? Obviously, you just can't rely on the event logs. You need to end-to-end test of each one of your services, or else you're running blind. And it's
it just seems like you guys would be a real source of information for PSS. As Win 2000 Exchange is deployed to the world, they're going to be running into a variety of things with these huge corporations that you guys have already run into.
Yeah. Well, I've actually handed off all our alert and definition rules to many companies.
So you go to our customers directly, not even through the support.
Either in EBCs and that kind of stuff. That's the first thing they ask for. Hey, what do you guys monitor? And I'm like, oh boy.
The sync between IT and PSS is terrible.
Really?
At least in the NT space. I mean, somebody might be able to sit here and tell me differently. But in the NT space, no, I know somebody from my team might be able to contradict that. But in the NT space, it's very bad. And my team, we have PSS engineers rotate over. They were coming in every couple of weeks and staying for a week or two and learning what we were doing with the directory, basically, or with Windows 2000 debug in general, maybe, for the past 6 months or a year. So they've been coming through and individually maybe gaining a little knowledge, but it's still very much catch as catch can. I don't have time to set up a program for them. They don't have time to set one up for me, but we're happy to invite them in and let them share our pain short term.
Okay. So, do you have a RAID equivalent or an issue tracking system?
We use RAID. We bug directly into dev. Sure.
No, but your own system of what type of issues you are facing and resolving, do you try to do a knowledge management or tracking of that a product groups could look at or we could look at to look for trend or type of issues you face there on a daily basis?
Yeah. Can I?
Yeah.
I think there's two parts of that. Right? We call it the annotation of the outage, right? So in Frank's world, a trouble ticket might be cut. And somebody says, my box is not serving web pages. And he might have seen an event in the Ops console, and people can be notified many ways that the box is not serving pages. They go over and take a look at it. They say, yes, it's not serving pages. The resolution was we bounced the service. That data sits in one disparate system. Then we go into our event collection systems, whether it be Frank's World or other types of event collection systems, and we see a service stop and start event. We don't know why, because that information has not been reflected in the same event stream that we currently have to do. That's what I call correlations, correlating the epics that went on around some outage. The other stuff is like, if I see these 12 things, I know I'm about to die, so let me correlate this information and take some type of proactive action. That's another type of correlation. They're both required. We don't have one today that does, puts the post annotation of why the outage occurred. I mean, I'm sure you guys know about our other tools that we use. We have a poor implementation of Office. It's called Office Assist. It's for the people on the floor while they're going to do something to a box. They say, I'm going to reboot the box because there's been a problem reported ticket number 123. Bjorn he took our concept and our idea, what we wanted for different API changes with the shutdown API and the service control manager API, and took it back to dev to see if Whistler could make some changes so you could have an opposites-like tool when people do reboots, so that puts an event in the event log that says I'm rebooting because there's a problem and this is the category of failure. I mean, sure, in theory those things are, that's great because that helps explain why the outage occurred.
Right.
The thing that I've always talked about my panacea, but not from a job security standpoint, but the K-Analyze tool that they have to do the analyzation of mini dumps. It'd be very interesting to see every single service owner create an analogous type of filter that would sit on IIS or sit on SQL to do that triaging of the events. Build this big pattern matching database down the road, so you could say, well, yeah, I've seen this type of stop code 2 million times. It is a problem. Let's prioritize instrumenting a box to really look what stop code 2000 is. But they're already doing stuff like that.
Sure.
Or thinking about it.
Well, they have already a program that if you have a dash, you could submit to it, but it's voluntary.
It's voluntary. It can't be voluntary. It's got to be, something on the box that does and looks and says, I'm going to die.
Well, like the way CA does it, right, with their Nugent technology. It's going to sit on the box for XYZ number of months, look at its failure patterns, and then say, okay, yeah, I can predict within 80% that it's going to fail now. That type of mentality. It's interesting. Yeah. I don't know how it will be implemented, but...
Right, I think feedback to the product groups definitely varies by product, and I think we're pretty good at giving true product bugs back to the product group, but lessons learned or ideas going forward, that's definitely not a priority that gets necessarily fed back to the product groups in a consistent manner. We'll have these one-off meetings where we give them our ideas. We've tried to establish a process where we get better about giving the feedback to the product groups just recently with a couple of new areas. But we're much better at giving true issues or bugs than we are about lessons learned or ideas for improvement.
Unfortunately, we really don't do a very good job at root cause analysis and tie it out of the ticket. A lot of the information's in the ticket, but we don't have all the configuration data, last state of the box. What had actually happened is the tricky part. It'd be nice if you could get a snapshot of that and go with the ticket.
We could solve part of that with procedural ways of solving some of that, and then also better integration, communication between different groups that are building event monitoring systems, configuration management systems. Sure, in a perfect world, someone would develop a tool within Microsoft that does your event monitoring and configuration management. And yes, all of this information can be shared amongst the 3 discrete functions that this tool does, but that doesn't live today.
Well, there's a movement in the distributed management team to do that. It's not all of that, but a good chunk of it.
Yeah. So maybe we should now take a round and ask everybody to give their own. You mentioned that may not reflect your true world. So if you want to go and give us maybe top 2 or 3 issues you see as part of your tool?
But basically, I spend a lot of my time looking at events to learn patterns, because I'm trying to improve my platforms that run IIS and SQL. So I can only improve my platform as much as an event tells me. I'm not going to open. It's a black box to me, so I don't know what's going on into it. So if I see these events, I get curious. I start researching why I would see these events, what code paths trip these events, determine if these are meaningful events or meaningless events. And then the next rev of a IIS or SQL server, my first cut is always to prove that those events still exist or what they were replaced by. And that's actually a very time-consuming, non-scalable function that me or people on my team do. And I think anybody outside of Microsoft wouldn't go to that level of discovery to determine if their service is running properly.
Could he benefit from learning about machine learning?
Yeah. I think there's some pretty strong groups inside Microsoft Research that look at machine learning techniques where what they love nothing better is 200 million events, and some of the categorizations that you've done in the past, and looking at ways of generalizing from that.
I think we talked with a couple of your statisticians, and the problem is that you have to weed out what we already know. Otherwise, it's going to give you a lot of stuff that we already know. If you just take it black box, it's going to output a lot of things that are trivial to us. So unless somebody sits down and still weeds out what we know, and then the leftover, give it to machine learning, then it's not going to work. That's just my
right. But you're in no worse situation there, because you have to read them out by hand now. So the hope is that the benefit of weeding them out is that you'll get some useful software out.
You get some correlations.
Yeah.
But I would think actually the product groups would want to take your machine learning. They'd like to go say, hey Frank, give me 2 months worth of events on the top 2 websites. Let me go and look at their event logs for 2 months, and since it's available in SQL, if your machine learning only works on raw event logs, well, the first thing would be to extract that out into something that could actually go and query a database and look at all of these interesting patterns and do something. But I don't think that should be the job of a customer of the service.
Sure.
That's me. So you should go to Andrew Cushman and IS Development and say, hey, you guys need to make this part of your ship criteria. Get 2 months worth of events from the product, from ITG, and see what you can do with them.
Yeah, it's probably true. On the other hand, they're going to come back to you in the end anyways, because they don't run servers in production environments the way you do.
We'll be happy to provide the data. We have the database with a billion rows of events.
1.8 billion rows of events.
Good.
You need to switch jobs for a couple months.
Yeah, we spoke to, what was her name? Cookie Sue Cookie? They got some analyzing for Windows Millennium. They got some research and technology.
Oh,
SUNY, sorry. Got the sheet for Millennium. They did some stuff with Sue Cookie to do some learning from the mini dumps, and then basically say, hey, this pattern is solved by redirector dot blah 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 version 123. Download off Microsoft.com and you're good to go. I didn't see how that scaled either, because you have these huge dump files, whether they're mini or large, that people are going to be sending back to the mothership here for analyzation, when you should harness the power of all those machines out there to do the analysis, send back and say, hey Microsoft, your field is seeing 2 million events like this? Gee, we never knew that.
And they were going to do it for desktop.
They were going to do it for desktops. It was a good idea, but I think a bit of a flawed implementation.
Anybody else?
Do you guys have a lot of complaints about server performance? Then you have to go and debug the performance as opposed to sort of failures?
We're finding it every day.
Yeah, and so now we're hearing from everybody. Yes, on the OS side, do we get into that? Certainly. Does Exchange do that? I mean,
we're fighting both our own servers and the Active Directory. We had to do some really non-natural things get the exchange service to run.
Every time I talk to the SQL people, they say, Sean, you don't understand. You're an MT debug guy. You don't understand. If we get into when you get into SQL, you're not talking about a down system or an access violation. You're talking about performance. So, yes.
And it's not performance of the storage engine. And in some cases, it's performance of the application. Somebody writes a poor SQL statement that consumes 90% of the system resources or does a table lock, and then that causes downstream processes to fail. There's no tool there's nothing that you really can do, pre-deployment outside of unit testing to confirm what impact it's going to have on the overall service, unfortunately.
And a lot of the time, and imagine if we have 5,000 production boxes out there, let's take a guess that 2,000 of them aren't performing all that well, and because people aren't feeling the acute pain, you never really hear about it. But do we think our server base is optimized across the board? I don't.
So do you reduce the performance drawbacks also with events?
Sorry.
Sometimes they may help in that diagnostic. Sure, when you're playing detective, you're going to look at the events. Sure, I mean you're also going to look at perk counters and stuff like that. But yeah, a combination of things. Protocol specifically.
Yeah, well, another issue that maybe we're touching is how effectively are those machines being used, right? Capacity plan. And as you can imagine, when you have so many machines, if the downside is losing customers out there, then people tend to over-engineer, right? So a lot of the products really don't show up because a lot of systems are over-engineered. So one of the things we've done is a methodology to be able to extract from performance counters the proper scaling of machines based on the humongous amount of data that we collect from the field. And having that in an automated or semi-automated way is pretty good because we cannot afford looking at each one of these boxes individually or at each one of these applications from the bottom up. So we basically take the systems approach in adding resource costing. And from an administrator's point of view, the only thing we care is how much of the hardware we're consuming, how much memory, how much CPU, how much disk, and how much network. And if we can come up with a pie that determines that, there goes the configuration of the machine and how many machines I need for each one of the services. And that we have done based on homegrown systems that we have. That's an option to that. Perhaps that goes towards the kind of question you asked. So that we don't have. One of the things that the properties of it are highly distributed. So again, it's one of those things that they give it to the last guy that just came in to figure out how many machines they need. So trying to avoid that or providing a ready solution to that, just derive out of performance counters is a very good first step.
Plus, a lot of it, like in the SQL space, a lot of these engines are, component. The scaling is limited by the way the components were written. So if somebody chose a poor threading model and what they did, it doesn't matter that we know that IIS is going to scale to N. Their component doesn't scale with it, and it causes negative scaling of the entire box. So,
and typically what we have found is that most of the models that are tested in the lab have worked in the field because of a number of reasons we can go into that. So there's no replacement for field data basically to do extrapolations.
So what happens when in that scenario, somebody starts running their application and all of a sudden the performance sucks? Do you see the performance debugging, or do they?
Actually, it's kind of twofold. If the component is causing the entire box to fail, so AV or more than just total havoc on the entire site. Sean's team does a lot of detailed debugging on that and says, okay, well, it's zeroed into this component, and I think it's in this call that the component's doing. Have the developer of that component look into it. But a lot of times we don't see hard failures, so we just see, the box has been characterized to serve, 20 pages per second. during the peak times of their business day. But now they introduced this new component, and now it's doing 2 pages per second. Well, what is this component doing? Well, let's first take it back to our stress lab and see what we can we emulate the behavior? We can. Yeah, this is basically what's happening. You're waiting on a back-end dependency that you didn't test in your environment. Geez, well, we didn't realize we were, synchronously waiting for the back-end dependency. We just assumed that by some rhyme or reason we were going to get the request back home as fast as we were going to get it in our little lab environment as you would in production. That's not the case. They don't have the same type of switch network. So we have a pre-production facility where the properties can come and do stress testing, but it's at their discretion. We don't make it mandatory. We used to do that when we were part of that. Part of us were part of the other property.
Yeah, that's on a one-to-one level, applications have changed, but on a macroscopic level, if you want, like if you go from SQL 6.5 to SQL 7, well, we compute the resource cost of hardware per unit of load. So based on that, we have a measure, the before and after. So, if there is a large difference, and it's a difference across the board for all applications, then we will contact the product group and notify them. And, oftentimes they have seen that kind of thing in another way. It's just that we happen to quantify it based on our workload. The workload we see in the CDC or in the IDC.
It's a it's kind of like a form of detective work that we do.
So what kind of tools would you want to see for that?
I've been pushing this on-the-board triager for anybody who will listen. And I've sent mail to a lot of folks on it. For me, I would love that. Doing the performance stuff, the problem with T-SQL and ASP is that it's simple, not trivializing it, it's simple enough that anybody can do it, and usually people that are doing this type of development, take a lot of shortcuts, and those problems get exacerbated underneath the load. So I don't know if you're going to create a tool to go out and look for syntax in T-SQL that's formatted correctly, that they're doing the right string manipulation.
Optimization.
I don't know if
it should be.
They do that.
Right. So
it's whether they do or they don't, it's called the CAP program, and they have analogus for other technologies for Core OS, the various infrastructure services that run on the OS, as well as SQL and IS. But they're not going to hold up their entire ship cycle just because we say it's 20% more costly on version 1 than version 2. They say, hey, that's interesting information. Can you give us the repro case? Can we still, is this too much of a drawback to ship? And then they basically have to make that call themselves. We don't say, hey, if you don't pass go, you can't leave.
And in fact, that was the question. You're saying that you can't stop them at the moment. If you could, do you think that would make things change quickly? In other words, I'm saying, could this be characterised as a reporting management type issue? The fact is that you're the customer and they get to screw you without any consequences, so they do it.
It's not as bad as that. They're getting much better. Tracy should talk to this. They target key applications within Microsoft as their primary. We must prove that their application can run and run well on the next version of whatever before we can ship. But again, for the people that inherit that new next version, it becomes a lot of work that's over and above their normal business function. Hey, I'm in HR. I just care that I can cut a paycheck for you tomorrow. I don't care that I'm running SQL 8.0 versus SQL 7.0. But a group of engineers like we are say, hey, well, we want to be true to the product group, and we want to make sure 8.0 can perform their application. So we do a lot of horse trading, and then we do a lot of hand holding, and we babysit it so it can make that go. But that's what we've signed up to do. Could some of that be automated somehow? I don't know.
But I think you were asking more from point of view of SQL. If we decide to go to the next version of SQL, do we provide a stop there if the version doesn't carry? That's what you were asking.
I'm just trying to understand,
right,
whether this really is a tool or whether part of this is the management issue. In some organisations, development reports to operations.
Right. Well,
not in this case.
Well, I understand that, but I think that caused a very, very different mentality.
But I think from a performance point of view, that would be also a little bit too late, right? Because by the time we get the version, it's already, late beta. So So it's a lot of things are already decided, right? So I don't think there is a program before that for checking the code if it has certain performance. I haven't heard from it. I might be wrong.
Really, IT's function in, I've been doing the same thing for about 6 years now, and it's always been Exchange. And quite honestly, we are the biggest data site that development has. Now, do we get our way all the time? No. Do we get our way about 40% of the time? Maybe. But what we're there to do is find the big bugs. I wish that we could get more input on UI, administration.
But that's just it. We've been doing this for 6 and 8 years, and we're having tremendous impact at the tactical level. But strategically, we get over these folks.
Right.
Clearly.
I've literally had bugs open for 5 years.
And they won't fix it.
Right,
And there is no teeth into the sign-off either. The later you get past the ship date, the later we are to market, the less teeth any kind of sign-off IT has.
And it just totally varies by product. I think that SQL is much more open to feedback than Exchange.
Give me an example. Try to get a bug fix or a DCR done in Office.
Well, I'm trying to work with the ITG to replace the heat, but I understand the pain deeply.
But I do know there is a big push right now from Rick to try to change that, from Rick W, to try and push a lot more of the Microsoft ITGs, your best customer, and you should start treating us that way rather than just your testing ground.
Well, at a developer level, individually, they know that. It's really choices that are made.
It's the strategy.
At the strategy, at the PM, very high levels. I've had guys in my office and, hey, I want to do this. And they say, so do we. It got cut. We think that'd be great, but it got cut.
Maybe that gentleman's comment, maybe development needs to report to up through this rank. I mean, seriously, but no, you just
sit there and do research.
I was thinking you guys can report to research. Set the hierarchy right.
The interesting point is that John and a lot of other people in this room have been doing stuff more than I've been doing in this, in that capacity of working with development. But you say it has bugs open 6 years. It's kind of product group by product group specific on if these bugs are going to get addressed. It's also who brought the bug to the product group. What credibility does that one individual have if that bug is going to be addressed?
That explains it. I wish it were just me, but quite honestly, a couple of years ago, the Exchange team brought in all these early adopters, sat them down in Building 16 for a week, and said, what do you guys want to see in the next version, which is now Platinum? And these guys gave great feedback, and a lot of the stuff was even better than the things that we were thinking of. But I'll bet you that maybe 5% made it into the product. And a lot of these things are core functionality, core administration. We want to know how to administrate public folders. It's a mess, okay? We can't. We do not have any tools. There is no methodology to doing it other than brute force, which you will take out the infrastructure doing.
It's not like those are new tasks. The public folders are done.
Yeah, they've been around since, we got a couple changes way early to actually make it so we could actually deploy them.
Right.
But other than that, it's dismal.
I'm hearing you guys say something else I've seen. There's a company out there called Smarty that sells heaps for Windows NT. And they sell one Smarty SMP for $20,000. And people actually buy it. Now, this is because they're so smart, or is this because our heat sucks so badly? I'm not going to say which one of those I think it is. But I don't see how they should even have a business.
Right.
Clearly showing them.
Yeah,
so what I'm hearing from you,
I don't know the architecture enough, but I've heard rumors that there's a lot of places that people know it can be optimized. They just won't because of fear of breaking legacy.
Right.
If we could pitch the whole thing and start fresh, I don't see that happening.
Yeah, let's not get I shouldn't even bring it up.
So if I could jump in with a separate question, one of the things that I've been thinking about is what tools would you guys accept, right? You asked us what tools we had, and one of the things that Sal had was dynamic instrumentation. I know you guys are real careful about what applications you'll run in the data center. If we were to give you a tool that dynamically changed code, in order to find something out, would you even consider running that, right? Like what sort of bar would we have to meet in order to make it into the data center?
So does that mean that we're not running the official version of NT anymore?
Yeah, so you're running the official version, but for instance, we've inserted a few probes to collect a little bit of data.
So Sean finds the bug, it goes to you.
Yes, so there's a couple issues here. One is stability. Gee, I don't know exactly what code I'm running, right? I don't know. You can know what you instrumented, but it's not exactly the gold code. There's the issue of performance. Yes, if you insert anything into the code, that's going to slow things down. And I'm just curious, what will you guys accept?
Then the benefits?
The benefits would be, let's say we can diagnose a problem, right? We see something going on in the event log, and then we say, ooh, I think it might be this, and the way I can verify that is if I put a probe here and see whether I hit it, right? Something like that.
We use instrumentation all the time, really. We use instrumented binaries, and we don't have any problem with that. I mean, typically we receive them from dev.
But this is a different model. He's changing your code in an automatic way that you don't even know, and he doesn't even know, which is even worse.
No.
Well, no, I mean,
it's not done remotely.
It's not done haphazardly. I mean, but there is sort of a question of what are you guys willing to run in a data center, right? Like if
in that scenario, I mean, sites that are clustered, like in an NLV sense, if a property has 4 boxes, if we could go to them and say, hey, listen, on one of your 4 boxes, we'd like to run this new whiz-bang instrumented, binary, and then we could have a test, which from our other monitoring type tools, either Cluster Sentinel or some of the things that Frank had talked about, and say, okay, well, this box is, starting to exhibit a sick behavior. Let's take it out of the cluster so the customer doesn't get a degraded experience, and see what your instrumented DLL tells us. But I don't know how.
So I think what he's saying is, if you had an ability to say, to give you a scenario to do this, you have an application, you want to see when does this application write to hard disk. Could you, if you had an ability to add that type of instrumentation yourself without going to dev, that you could put in an extra probe into that application to give you a feedback on, I know when a system is being written, but now I want to know when this component writes. If you had an ability to do that, would that be useful to you?
I think you're missing one point as well.
Okay.
Exactly what Jay says, but dynamically.
Right.
You walk up to a box, it's online, the customer's using it, you want to add in a probe and say, is this box that is acting sick doing this now? And after you've determined that, you want to back it out. You're not changing the exit.
So is there a remotable API that I don't have to walk up to 6,000 boxes to do that?
That's right, obviously. So you can remotely move it over. You can just put in the probe, find out the information on the world, real system, and then back it out and you're back to gold code.
But I mean, we just do this. We do this all the time in various ways.
I mean, it depends on the system. There's some applications we're not going to do that.
Sometimes we can, sometimes we can't.
With infrastructure, we can definitely do that.
But there's no religious issue of, gee, we're not going to run, anything that dynamically changes code in the data center.
I want to have a discussion with NTDev. If I'm talking about the OS, I think that we don't need to talk to NTDev and get on the same page about that, but I imagine that would be a reasonable thing, right?
I think everybody's room thinks it'd be cool.
I guess I would argue so how could your thing be smarter than I as a SQL server for designing this when they
I'm not talking about smarts here at all. Like I sort of outlined a situation that would require a lot of smarts, but you could consider it to be a very sort of dumb situation where you just you're seeing some funny problem in SQL Server. You talk to the developer and he's like, well, it might be something that's going on in that function or something like this, or I'd be interested in knowing if this piece of code is running. Now, you could, then manually go and use a tool and say, okay, I want to probe that piece of code just to see if it's running, and report back to me. But what's going on is you have something in the data center that is now running code that is not gold, and whether you'd be willing to to take that risk for the benefit of getting a little more data.
No, it's really just not much different. Like I said, we take instrumented code now and we apply it, and then when we're done with it, we take the damn binary off. I mean, you're talking about something far less intrusive than that. And although we have a standard platform, when we get down to break-fix work, I mean, we tear that platform apart and we'll put on checked builds, instrumented builds, whatever we need. So, yeah, if you just got, a smarter widget than we have now, and you're asking, would we be willing to use that?
Yeah. That's basically, I was wondering what your tolerance was for using instrumented binaries.
Can I extend that one a little bit? Let's say what do you want? Let's say that his idea, we have the code that does that, but it knows, it can figure out, well, since I've instrumented this and I found this, I want to go ahead and instrument this and find this. Maybe it generates a log back to you and says, I've chosen to do this.
So it learns.
So you know what's going on. But it's a kind of learn. Or maybe it looks at what's going on and says, oh, I can solve a problem by inserting this code because I can look at a database somewhere and say, oh, I know about this, and so I can insert this code and solve the problem.
This is just a logical, it just sounds like a very logical extension of what we do today, and we'd be fools to say no.
You want logs of what's going on.
Sure. Yeah, we just want to know the audit trail, that what it went through.
Okay.
And a reasonable assurance that it's not going to monitor the logs to death.
And probably the CDC.
Just
you have it today, or? We have some parts of it.
We have pieces of it. The real question is, are these pieces worth leveraging, or is this something that would be dismissed, offhand because of the fact that it is, possibly making dynamic changes to the system?
I would think DSS would love something like that to be able to put out their major clients and say, they keep on calling up and say we have a chronic problem. He goes, well, okay, let me go remotely and enable this. And I'm going to get a log back, and I'm going to be able to say, hey, this is what the problem was. You guys should go.
If it provides positive feedback, fixes the problem, helps debug, yeah, it's a winner. If it takes out the server,
Well, it's some percentage of the time it's going to happen.
Well,
right?
it's not
the idea is it should be a small percentage.
But it's still trying to do your mailbox is on it. And
But I mean, we pick up bad components all the time too, right?
Yeah, that's right. I mean, that's my point.
We say we need a fix. Well, it might take 4 times to really get that fixed.
Yeah.
We're not talking about it. This is not different in kind.
Exactly. When I say it could be a failure, that's because there's a bug.
Yeah.
It shouldn't have happened.
It's not an alien concept. It's just a new way of doing it.
No, it's very cool.
That's a good one.
No problem.
Next week.
We actually can demo some of this stuff.
Well, actually,
work on
but only in demo.
right now we can pick up R2 and if you're buying it.
Swedish guy.
One of the tool is the injector, and basically will allow you to submit any binary service or kernel mode, and you direct any function to anywhere today statically. The next version you'll be able to do it dynamically, which means all instrumentation is in memory, nothing on the hardware. I'll be more than happy to give you a demo.
So we should add a couple names on the IT side. Sean Webb, for one, is definitely one of the key guys to interface with.
Sean Webb.
With the cabinet glasses.
Yeah, that'd be very interesting.
Great. So there was I think a couple of months ago, there was a degradation of logging on to a log-on controller, right?
What's this?
So I'm just curious, what was the outcome of that? What caused that?
We've been spending 3 months. I mean, the last 3 months, actually.
It's still going on?
Before Exchange.
Yes.
We don't know what covers.
No, we know so much more today about DS than we did 3 months ago. It's incredible, but we still don't know everything. And we found out that NGWS didn't know a lot of things.
Right.
A lot of the assumptions that were made a year ago or more about how the Active Directory would be deployed and how Exchange would use it, about scalability.
About legacy clients would use it.
About how legacy clients would use it. A lot of those assumptions were flat out wrong. So, what we found just at a very high level is that our assumptions about scalability and how many resources, what kind of resources from a hardware standpoint we'd need for X size of Active Directory were largely incorrect. And we didn't have a lot of, going into it, if we had to buy hardware more than a year ago, about 18 months ago probably, in order to deploy, because we deployed 6 months before RTM. At that point in time, we didn't have a lot of numerical data on here's what you need, here's how much CPU you need. So we relied on a lot of generalizations, and we're just now within the last few months, and even more so within the past month, going back and reviewing the performance data to figure out where exactly we need to be from a hardware standpoint. So that's part of the problem. Some of the other problems are some of the binaries. The LSA binary wasn't compiled to take advantage of the 3 gigabyte tuning. So we go out and we try to solve a performance problem by adding memory to a box, and we end up crashing the box. So now we have fewer boxes in service. Just a comedy of errors like that over the period of about 6 weeks really seriously impacted the directory. But we've also found that Windows 2000 has given us all kinds of new instrumentation to see things we couldn't see before. And it turns out that a lot of applications, that particularly even within Microsoft, are really poorly written and really do dumb things in terms of how they query directories and domain controllers. And just an example, when SQL jobs fire up under SQL 6.x, they do a full group enumeration, which is fine on a 40 megabyte SAM. But when you have a several gigabyte Active Directory out there, and you want to enumerate all the groups in it, and we collapsed 400 domains down into one big domain with 100,000 groups in it, a single enumeration of all the groups in that domain takes a lot longer. So if you've got 2,000 SQL servers firing off 100 jobs a night, every time they're firing off doing group enumerations, you're taxing resources in ways that you wouldn't have been able to predict under NT4, because if you hadn't actually taken a sniffer and gone out and sniffed the traffic, you never would have seen this. You didn't have the counters for monitoring group enumeration. So we've been working day in and day out with the different various developers in the NT-Dev group, and they've been really responsive into addressing each one of these things as we find them. We're getting fixes in SP2 from just about every SP1 and SP2 for just about every one of the issues we found. And we're also getting little tweaks and performance orders and stuff to better be able to track some of these issues going forward. But it's been a real eye opener for us.
One of the reasons it's taking a lot of time is because there's really no tools to determine what's going on with the DC. There's a black box in there. Stuff is happening. It's running crappy, but God help you to know what's really going on. These guys did a lot of work to open that box up and figure out who all's hitting it and why and what the devil they're doing.
But it's still a day-to-day thing right now. I mean, we know we need more hardware. We know that's the first thing that we're going to try to solve. But every day we go in, and if we start seeing spikes, I mean, we have to fire up Network Monitor and get sniffs and figure out who's generating the traffic, figure out exactly what they're doing. It's not like there's one event in the event log that says, oh, go contact this user and tell them to stop doing X. It's still a day-to-day thing, and I'm not convinced that next week we won't come in and start having login problems again, because one, we're still underpowered. Two, there's some new behavior, some new application that's been put out on the network. Yesterday, we just found out proxy server every 5 seconds is going out and enumerating its configuration objects in the Active Directory. So every proxy server that we've got around the world, this is a new version of proxy server. And then this is, it's not released yet. It's but it's proxy 3.0. What we're going to find is that instead of having just one new product come out internally that's going to use Active Directory, in another few months we're going to have 2 or 3 of these coming out a week, and being able to detect what they're doing and why they're doing it, it's still a very manual, labor-intensive time.
You have upgraded this hardware for the Active Directory?
We stopped the hemorrhaging. We've done incremental upgrades in memory.
Wouldn't you say that there's someone should develop a better interface to get enumeration out of the Active Directory and then make sure everybody follows that standard?
To some degree.
That's more. Yeah. That's the way to solve it one-off for everybody. Create an interface to the Active Directory, not just always going through, WMI as an example, or ADSI compliant.
So this is exactly where injector type of tool could come in handy.
Yeah, it's more practices than anything else. When we're talking about enumerations being done left and right, it's probably programming practice at the very low level.
Yeah.
It's nothing to do with injection.
Right. It's
Yeah, I also went to a little talk about writing an LVMI provider, and it was enumeration left and right all the time. Well, you have 100 machines or 1,000 machines out there. You cannot just have it's very simple enumeration of your algorithm to walk through. So, anyway, that's just.
So how would you characterize the top 2 or 3 problems of Platinum deployment?
Most of our problems have been dismal testing before Santa does.
Okay.
The Exchange team, while they had a number of mailboxes in their environment on Platinum, they did not test in the scenario that most customers would use. What they have is a scenario where their Active Directory is only used for configuration information. All of their user objects are in the ITG world. Most customers will not do that. They will be fully integrated like ITG did. So as soon as we got the code, we started seeing problems of what happens when when the user is really exercising real DCs. So it really wasn't realistic testing. A good portion of problems that we're still finding, we've got a real nasty one going on right now, is based on directory access. So again, AD integration.
Yeah. What about the one that we would send mail, we wouldn't even know if people received it? The mail would leave our little view of the world, and weeks would go by, and we would say to somebody, hey, how come you never responded to our mail? And actually, some of the stuff was vendor talks that we were having. I never received your mail. So it's like, we laughed about it. That's terrible. I mean,
yeah. Oh, yeah.
Maybe
there's a scale issue, I don't know.
That was literally, and I made a big stink about it, that was literally mail that was stuck in a queue that there was no way to see. The only way to see if there were messages in that queue was to debug the server. To this day, the only way to see that queue is through perfmon. There's no WMI. There's no, it's not, the Exchange Service System Manager uses WMI. It's not shown in there at all. The only place to see it is if you run the code.
So there's a counter that represents the queue.
There's a counter that represents the queue.
But you don't know if, say, your specific mail is stuck in there.
I can't tell you what mail's in there. I can tell you that the mail is in there or not in there.
So
there's a lot of problems that created that scenario, but I pretty much, at that time they're going, well, we're about ready to ship, and I say, no, you're not. We will not sign off.
Other than trying to find 30,000 users to do real-life testing, is there a possible way to simulate this and have it real world, or?
They could have. About a year ago, I was over here for a 5.5 board team meeting, and one of the testing guys said, hey, by the way, are you guys going to use this scenario? And that's where you have corp and then child domains. And I said, yes, that's how we're going to deploy, and so will most customers. Oh, that's interesting, because we're only testing in a flat model.
Yeah,
and to my knowledge, they never really got into testing in a child parent, because when we started running setup, we started finding all sorts of problems, and they're going, oh yeah, well you have to do this in your root first, and so a lot of changes came through, like forest prep, domain prep. They hadn't planned on doing that at all. They made some really bad assumptions. Our view has always been that until recently, I know these got reordered, but because the Exchange team and the NT team were under Alchin, make them play in the same sandbox. I don't care about testing, version control, or anything like that, but it certainly would have gotten a lot of problems solved before we even saw the code. Because they would have been integrated with an AD that's at least has active users in it. The way they're doing it, they've got ADC or 2 to do their configuration stuff. Big deal. I got more powerful machines in my office.
And more users.
And more users. More active users.
The problem now is it costs a lot. So now, Exchange is done and they're going to ship. Now we're going to have other other groups, maybe SQL, who knows?
Yeah, but they're going right into Service Pack. As soon as they ship, they're going to turn around and start coding for Service Pack 1 because nobody's going to use Platinum the way it says.
Well, it's a communication thing. They didn't communicate with developers of the Active Directory soon enough.
Right. There's a real discord there. In fact, we were at a meeting, well, when the whole thing started out there, we're at this meeting. We had NT guys, we had Exchange guys. We're trying to figure out why our servers sucked. The NT guys and the Exchange guys had never met before. I mean, I got out of the meeting, who was it? Who's that? I said, you're kidding me. I mean, we know them all. And that's scary. We shouldn't be bringing the same, we consider them in the same sandbox. We should be bringing them together.
We had another comical one just with SQL 2000. We went and popped and got all this money to build this huge server with shared storage. We have an MSCS in front of it. And the thing died, and they couldn't actively debug it because they didn't have a debugger that would support a passive and an active cluster. They would have said, well, MSCS is going to fail over, that's why you went and bought all this hardware. But once it fails over, we can't debug it. You know, obviously the instance anymore is gone. And we're like, well, didn't you guys think about this one? I mean, that's a clear indication.
We're not even doing clustering right now because the story is so bad going forward. In fact, they limited the number of storage groups. The whole plan, the whole design is pretty dissonant. The fact that they've limited us in the number of storage groups we can have, the number of databases per, part of it's the way we roll things out, but we were literally running out of drive letters and ways to fail them over and things like that. And here's the situation. On any given server, you can only have four storage groups. You can have about 6 databases per storage group. We do about 4. Okay. Well, if you're in an active situation, that means that each server can only have 2 storage groups. And then they can only have 6 databases per. Well, if you're in an active, then you get 1 with 6 per. So really, where's the game? It means that our databases, we have to make our databases much larger, and that's one of our initiatives, is to make them smaller so we can actually back them up and restore them and massage them in a realistic time frame.
But isn't that an artifact of JetBlue that could be replaced by them using a different storage engine? And maybe it's outlived its lifespan for scalability and.
I don't know if we're still calling it Blue or not. It's not coming. Well, what it is, what they found was as they allocated more virtual servers for Jet, they were running the machine right out of memory.
Sure. I mean, the reason why they want to keep them small is because when you back up.
No, the reason we want to keep them small, and so does every other customer. Yeah.
But I'm just saying, I mean, that's always been a holy war between.
Oh yeah.
Why is that? We have a database in this company that's highly scalable and keeps on getting better. Why wouldn't we try to figure out how to leverage that storage engine?
Oh, that's a holy war.
That's my.
So your top 3 deployment problems. The first one was test in general. The second one was integration between Exchange and the Active Directory.
And then we've had a lot of problems too. And a lot of them have been a few of them have been very odd, because one of the problems we've been having is literally fighting terminal server. The way the terminal server shipped